The story that the Méré utilized such a naive argument to compute probabilities, leading him to the mistaken conclusion that the two cases were equally likely, is suspicious at best. The Méré, the historical record shows, was actually quite proficient mathematically and technically, and it's rather unlikely that he would have made such a speciously incorrect argument, especially one which was so quickly susceptible of a disproof. The idea that he could discern the difference between the two cases because of repeated experimentation and gambling by winning a great deal on possibility A and losing a great deal on possibility B is perhaps even more unlikely on the face of it. Now, this is going to require some analysis, but the student will be willing to accept that the possibilities are actually very close to each other. Both of them have a chance of very close to 50%. In fact, the difference between the two cases is about 3%. Now, if one were to toss a coin, for example, and try to determine whether it was fair, 1, 2, 3, and so forth, how many tosses would be required? Well, the student could well imagine that one would need a fair number of tries to get enough data to form an accurate estimate. And in this case, the estimate is particularly delicate. We have to do the experiments often enough, gamble often enough, to separate two rather closely placed hypotheses at 0.52 and 0.49. Now, we'll come back to this issue later on because this is going to be at the heart of mathematical statistics. But it is clear that the number of trials is not going to be something like 100. In 100 trials, would I be able to separate 0.52 from 0.49? Seems unlikely. And in fact, the number of trials is going to be something like the order of 5,000 trials. It's very hard to imagine that someone played this game 5,000 or 7,000 times, and not only play this game. You can imagine, let's say, a smoke-filled tavern where people are gambling. But you're not just gambling, but in the heat of the moment, you're also keeping track of every one of the results of these 5,000 gambles or trials. That sounds incredibly implausible. But nonetheless, it's a good story. Now, we've got an idea of how to begin by analyzing a very simple game of chance in a historical context. What are the key elements we can abstract from this? Well, the idea that you have chance experiments where the results are not a priori determined, whose results are outcomes, and so now there's an idea of trying to characterize completely the possible outcomes of the experiment. And then there are events of interest to us which you could identify with aggregates of outcomes. And finally, there's an idea of chance, a probability measure, which quantifies the chance of a particular aggregate or event happening.